Hello everyone, today we'll be looking at the quick solutions to the chemistry section of All India AIATS Test Series JEE Advanced 2021 Test 1A Paper 1 Code ENF. So let's start with the first section, students. So students, the first section contains 6 questions. Each question has 4 options, out of which one or more than one option may be correct. Okay, so let's start with question number 19. So question number 19, it says 1 gram of magnesium is heated strongly in a vessel containing 0.5 gram of O2 to form MgO. Which of the following statements is or are correct? So the atomic masses of oxygen and magnesium have been given to us. So the examiner seems to be interested in the concept of limiting reagent in this question. So let's try and figure out the reaction. Okay, so students, we know that magnesium, it reacts with half oxygen to form MgO. Okay, so looking at the stoichiometry, it is clear that 24 grams of magnesium will react with 16 gram of oxygen to give us 40 gram of MgO. Okay, so now students, it is given to us that magnesium taken is 1 gram and the amount of oxygen taken is 0.5 grams. Okay, so students, we can clearly see that the limiting reagent is the oxygen in this case. It is present in a lesser amount as required stoichiometrically for magnesium. Okay, so the reaction will be governed, or it will proceed according to oxygen. Okay, so the examiner seems to be interested in the amount of MgO that is formed and the amount of magnesium which is left unreacted. Okay, so students, we can see that 40 grams of magnesium are formed from 16 grams of oxygen. So it means that 1 gram will form 40 upon 16 gram of magnesium. And if we talk about the actual amount which is given to us, that is 0.5. So we just have to multiply that. So this is the amount of MgO which is formed upon reaction with 0.5 gram of oxygen. Okay, so this will cancel 2 and 5. Okay, so this will give us a value equal to 1.25 grams. So the amount of magnesium oxide which is formed is equal to 1.25 grams. Okay, now if we talk about the amount of magnesium which is left unreacted, again we can see that 24 grams of magnesium react with 16 gram of oxygen. So it is clear that the amount of magnesium which is reacted with 0.5 gram of oxygen shall be equal to 24 by 16 into 0.5. So 8 will cancel it 2 times and 3 times. So this will be equal to 3 by 4, which is equal to 0.75. Okay, so this much gram of Mg has been reacted and these many grams of magnesium oxide have been formed. Okay, so if you look at the options which are given to us, students, option A, it says 1.5 gram MgO is formed in the reaction. This is not correct, students. It is 1.25 grams, which is given in the second option. So option B is correct. If you talk about the third option now, O2 is completely consumed in this reaction. This is also correct, students. O2 is indeed the limiting reagent in this case and it will be completely consumed in the reaction. If you talk about the fourth option now, 0.25 grams of magnesium is left unreacted at the end of the reaction. So this is also correct, students. Initially we had taken 1 gram. Finally 0.75 grams had been consumed. Okay, so the amount remaining is the difference of these two, which is equal to 0.25 grams. Okay, so students, for this question we have to mark the correct answer as option B, option C and option D. Okay, let us look at the next question now. Question number 20. So it says, to understand the process of vaporization, it is assumed that the molecules in the liquid have a distribution of the kinetic energy same as the gases have. That is the Boltzmann distribution. So those molecules moving away from the surface and toward the vapor phase will escape only if their kinetic energy is greater than a certain minimum value. Okay, for the vaporization, when liquid and vapor are in equilibrium, following Boltzmann distribution curve is obtained for liquid phase at different temperatures. Okay, so let us start with the options given to us, students. Option A, it says curve P is at a lower temperature. So if you look at the two curves given to us, students, curve P and curve Q, we can see that the curve Q should be at a higher temperature as it is flattened and the peak also shifts towards the right. So curve P is at lower temperature, whereas curve Q is at higher temperature. Okay, so the A option is correct, students. Let us look at option B now. If the temperature is raised, the particles belonging to curve P may come under curve Q. So this is also a correct statement, students. As the temperature increases, the curve becomes flatter and the peak shifts towards the right. Okay, so option B is also correct. If you talk about option C now, molecules belonging to an area R have a greater tendency to get evaporated as compared to the molecules of area S. So this is not correct, students. If you talk about the area R, so the area R represents a lesser kinetic energy. We have plotted the kinetic energy on the x-axis. So area R corresponds to a lesser kinetic energy, whereas area S, if you look at it, it corresponds to a region where the kinetic energy is greater. So students, this statement is not correct. It is the particles which belong to area S which have a greater tendency to escape into the vapor phase as they have a greater kinetic energy. So statement C is not correct, students. If you talk about the statement D now, molecules moving with greatest velocity would be found in area S. So this is correct, students. The molecules in the area S have greater kinetic energy. It means that they have greater molecular speeds or molecular velocities. Okay, so statement D is also correct, students. So if you talk about the options which we have to mark for this question, students, we have to mark option A, option B and option D. Okay, let us look at the next question now. Question number 21. Gases such as methane are supplied in steel cylinders. Okay, so it is given to us that at 27 degrees centigrade, a 15-liter cylinder contains 60 mole of methane when full and 0.6 mole of methane after prolonged use. Okay, so values of A and B for methane are 0.25 atmosphere liter square per mole square and 0.05 liter per mole respectively. Okay, so it is given to us that the value of R is to be used as 0.08 atmosphere liter per mole Kelvin, and we have to identify the correct statement. Okay, so looking at the options, we can see that the examiner seems to be interested in the nature of the gas, that is whether if it behaves ideally or if it behaves in a real manner. Okay, so if we talk about the condition when it is full, students, so we can first start with the van der Waals equation. So we can find out the pressure using the van der Waals equation, and then we can use the ideal gas equation for the same, and we can see if both the pressures, that is the pressure predicted by the van der Waals equation and the pressure predicted by the ideal gas equation, are the same or not. Okay, students, we know that van der Waals equation can be written as P plus A n square by V square into V minus NB is equal to nRT. Okay, so we can do a little rearrangement over here, students. We can have pressure is equal to nRT upon V minus NB minus A n square by V square. Now students, for this real gas equation, all the parameters have been given to us. The number of moles given to us is 60. Okay, the volume given to us is 15 liters. Okay, and the value of A and B are given to us. Value of A is equal to 0.25 and the value of B is equal to 0.05. Okay, so we need to just substitute these values into this equation. So we can have 60 into 0.08 into 300 upon V, the value of V is 15, minus 60 into B, the value of B is 0.05, minus of A, which is 0.25, into number of moles whole square, which is 60 square, upon the volume square, which is 15 square. Okay, so students, this on simplification gives us a value equal to 116 atmosphere. Okay, so students, if we talk about the ideal gas equation now, if we apply the ideal gas equation when full, so the first case was assuming the real gas behavior. Now if you talk about the ideal gas behavior now, students, we can directly have P equal to nRT by V. So we can just put these values. N was 60, R is 0.08, the temperature value is 300 Kelvin. Okay, upon the volume given to us was 15 liters. So students, if we simplify this value, we get a value of pressure equal to 96 atmosphere. So students, we can clearly see that when the cylinder is full, the pressure exerted by assuming the ideal gas behavior and the real gas behavior are both different. Okay, so students, we can clearly see that when the cylinder is full, the methane will behave like a real gas. Now if you talk about the behavior of the gas after prolonged use, students, so when it is used for a long time, so after prolonged use. So now students, we have the number of moles equal to 0.6. The other parameters are the same, students. V was equal to 15 liters. The value of A was equal to 0.25 and the value of B was equal to 0.05. Okay. So similarly, we can again find out the pressure assuming the real gas behavior. Okay. So we had P equal to nRT upon V minus NB minus of A n square by V square. So students, we can just put the values as we had done before. So N is 0.6, the value of R is 0.08, the value of temperature is 300 Kelvin, and V was 15, the value of number of moles was equal to 0.6 and the value of B is 0.05. Okay. So we can also put the value of A n square by V square. A was 0.25, the value of N was 0.6, so we have to square this value and the volume was equal to 15 square. Students, if we simplify this value, we get a value of pressure equal to 0.96 atmospheres. Okay. Now if we assume the ideal gas behavior, students, so the pressure will be given by directly nRT by V. So we can just put these values. N was 0.6, R is 0.08, temperature is 300 kelvins, and the value of volume is equal to 15. So if we simplify this value, students, this will also approximately come out to be equal to 0.96 atmospheres. So if we talk about the behavior of the methane gas after prolonged use, we can clearly see that the pressure exerted by the gas is predicted to be same by both the van der Waals equation as well as the ideal gas equation. So it must mean that the gas behaves ideally in this condition. So students, if we talk about the second statement now, it says when the cylinder is considered after prolonged use, the remaining gas behaves almost ideally. So this is correct, students. To talk about the third statement now, in both circumstances, full and prolonged use, methane gas behaves almost ideally. This is not correct, students. In the initial stage, the gas did not behave ideally, but when it is considered after prolonged use, it behaves ideally. Okay. If we talk about the D option now, methane gas never behaves ideally. This is also incorrect. So out of these given four statements, student, we can clearly see that only option B has to be marked as the correct answer to this question. Let us move on ahead to the next question now. Question number 22. It says a gas obeys P into V minus B equal to RT. Okay. Select the correct statements about this gas. Okay. So in the first option, the examiner seems to be interested in the isochoric curves plotted between P versus T. Okay. So if we talk about P versus T, students, we can clearly see that P can be written as R upon V minus B into T. Okay. So we can see that it has a straight line nature and the value of slope is given by R upon V minus B, students. So the statement given in option A is correct. If we talk about the second option now, isobaric curves, which is V versus T, have slope equal to R by P and intercept equal to B. So students, we have to now talk about the graph of V versus T, which is plotted at constant pressure. Okay. So if we talk about the second statement now, we can have V minus B equal to R by P into T. So we can rearrange this to get V equal to R by P into T plus B. Okay. Students, we can see that this is plotted on the y-axis, whereas this is plotted on the x-axis. So this must be equal to the slope M and this should be equal to the intercept. Students, the intercept is equal to B and the value of slope is equal to R by P. So students, the second statement is also correct. If we talk about the third statement now, for the gas, the compressibility factor is equal to 1 plus PV by RT. So students, for the compressibility factor, we need PV by RT. Okay, which is given by Z. So we can just expand and rearrange this to get PV minus PB equal to RT. So we have PV equal to PB plus RT. So if we divide both sides by RT, students, we're going to get Z is equal to 1 plus PB by RT. Okay. So students, this is a correct statement. The value of Z is given by 1 plus PB by RT. Okay. If we talk about the D statement now, it says that repulsive forces dominate over attractive forces. This is also correct, students. in this equation, A is approximately equal to 0 or it is missing, which means that the attractive forces are very weak. Okay, so it means that the repulsive forces dominate over the attractive forces. So the fourth statement is also correct, students, and for question number 22 we have to mark all of these given statements as correct. Okay, let us look at the next question now. Question number 23. The Schrodinger wave function for a Bohr atom is given by psi radial equal to some function which is given to us, where A0 and Z are constants and sigma is equal to 2ZR by A0. We have to find out the correct minimum and the maximum position of radial nodes from the nucleus. So students, if we talk about the given function, we have been given psi as a function of R in this case. Okay, so the examiner seems to be interested in the position of the radial nodes. So students, to find out the radial nodes, we need to find out the positions, or those are where the value of psi square is equal to 0. And if you look at the function of psi which is given to us, we can directly see that psi square will be 0 when this term inside the bracket is equal to 0. So if we talk about the psi square or the psi being 0, we are going to have a value of sigma equal to 1, or sigma square minus 8 sigma plus 12 equal to 0. There are no other zeros for the function of psi apart from these given values. Okay, so if we simplify this, this is a quadratic equation. It can be solved as sigma minus 2 into sigma minus 6. Okay, so we can see that there are 3 roots. So sigma can be equal to 1, 2 or 6 for a radial node to occur. Okay, so the value of sigma is given to us. All that is left now is to substitute the value of sigma in terms of ZR by A0. So for the minimum value, sigma has to be 1. And for the maximum value, students, the value of sigma has to be 6. Okay, so 2ZR by A0 is equal to 1 for minima, or for the minimum value. So R shall be equal to A0 by 2Z. And if we talk about the maximum value of R for which a radial node occurs, it means that 2ZR by A0 is equal to 6. So in solving this, we have R is equal to 3 A0 by Z. Okay, so if you look at the options which are given to us, it says the minimum position occurs when R is equal to 2 A0 by Z. This is not correct, students. Option C is correct, which says that the minimum position of the radial node is A0 by 2Z from the nucleus. So statement C is correct. If we talk about option B and option D now, we can clearly see that out of option B and option D, the correct option is option B, which says that the maximum position of the radial node is equal to 3A0 by Z, which we had calculated just now. Okay, so option B is correct and option D is not correct. So for question number 23, students, we have to mark the correct answer as option B and option C. Okay, let us look at the next question now. Question number 24. Consider the following molecules or anions. Okay, so we have been given 4 different compounds, X, Y, Z and T. So we have to comment on the structure of X and Z. Okay, so if we try and draw the structure of these compounds which are given to us, students, we can have HPO2F2. So P double bond O, OH, F and F. So this is the structure of X, students. If you talk about its anion will just lose this proton. So P double bond O, O negative, F and F. So this is the structure of Y. Okay, we can also now have the structures of HSO3F and SO3F negative. So if you talk about the compound Z, we have S double bond O, F and OH. So this is the compound Z. And if you talk about the compound T now, it is SO3F negative. So again, in a similar fashion as before, this H will be lost to form the given anion. So S double bond O, F and O negative. Okay, so these are the structure of the compounds which have been given to us, students. Now if you look at the options, option A, it says both X and Z have one OH group each. So this is correct, students. We can clearly see that both the X and the Z, they have one OH group each. Okay, if you talk about the second statement now, hybridization of phosphorus in compound X and Y is same. So this is correct, students. In both these compounds, the hybridization of phosphorus is sp3. Okay. So statement B is also correct. Let us talk about statement C now. Hybridization of phosphorus in Y and sulfur in Z is same. So again, students, if we talk about the hybridization of sulfur in Z and T, they are also sp3. Okay. So option C is also correct. If we talk about the D option now, shapes of X and Y are different. This is not correct, students. Shapes of both X and Y are tetrahedral. So they are both the same. Okay. So students, for this question, we have to mark the correct answer as option A, option B and option C. Okay. Let's look at the next section now, students.